So we're on page 18. Is this section 1.3? Okay, so we're talking about counterexamples. So a counterexample just means something that proves our proof not to be true. Okay, so somebody says something and you say, no, it's not because of this and this and this. That is a counterexample because you're taking what was said to be the truth and then you proved it wrong. Okay, so make sure you know the definition for counterexample. We can say proving proof invalid or not true, something like that. Okay, so our first example here, I'll move the page down. So what we're doing is, it says, as the number of points in the circumference increased, Carrie noticed that the pattern from the number of regions created by the chords. Okay, so she notices a pattern. So she makes a chord. A chord just is one point to the other exterior point of a circle. And so one chord that's got 2 points, and it made 2 regions, 1, 2, right? So then when she has 3 points, so a chord, a chord, a chord, 3 points on the exterior of the circle, it now makes 1, 2, 3, 4 regions. Okay. Then she has 4 points on the outside of the circle. Okay, and it makes 1, 2, 3, 4, 5, 6, 7, 8 regions. Okay, does anybody notice the pattern that's happening? Doubling, yeah. The number of regions are doubling. So, because it's going from 2, 4, 8, the next one should be 16. So if I had 5 regions, I don't know, I could try to attempt it, but 1, 2, 3. One, 2, 3, 4. No, I got 6 dots, don't I? One too many dots? Oh boy. There we go. Okay, hold on. We want 5 dots, right? 2. Okay, so then we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I missing something? Oh yeah, here we go. We gotta go here too, right? Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so it worked, right? Okay, so then the next one, if we had 6 dots, it should be, yeah. But if with our conjecture that we made, it should be 32, right? If it's doubling. But if you actually drew it out, it's not 32 at all. It's actually 31 regions. Okay, this is a counterexample. Okay, because if you actually worked it out, then you would notice that the regions were only 31. Okay, so you just found a counterexample, meaning you found something to prove the statement invalid. Okay. Okay, let's move to another example. We'll keep going. We'll go to example 3. Okay, so example 3 says, Matt found an interesting numerical pattern. So 1 times 8 plus 1 equals 9. And then he goes 12, which is like 1, 2 times 8 plus 2 equals 98. And then he goes 1, 2, 3, which is 123 times 8 plus 3 is 987. And then 1, 2, 3, 4 times 8 plus 4 is 9876. Okay, so what would be the next numbers in this pattern? Okay, Sorry, I gotta erase all this. Okay, so 1, 2, 3, 4, 5. Whoops, sorry. There shouldn't be a comma in there because it's a number. 1, 2, 3. So 12,345 times 8 plus 5 equals 9,876.5. And if you check it, it actually does. Okay? And if we did the next one, it works out. If you do the next one, it works out. Where do you think this falls apart? Where do number tricks always fall apart? Or it worked in 1, so what's that? Yeah, after 9 is 10. That's where it's going to fall apart because it's 2 numbers, right? 2 integers. Okay, so if you got to 10, so if you were to do that, it doesn't work out. So that would be the counterexample for this. Okay, so everything's good when you're following a pattern, and as soon as it falls apart, that piece that shows that it's not right, that's the counterexample. Okay, I think that was the last example in the textbook, so we'll just follow the lesson that goes with it.